Hi, welcome to episode 2 of Mrs. Mills Science Time. I also want to encourage you to take a look, if you get a chance, to my STEM and STEAM Teaching and Learning Journey website that can be found just under that name. And there's lots of activities for teachers, classes. If parents want to join in with their kids, feel free. It's always free. So today we're going to take a look at liquids again, and this time we're going to do some density activities and learn about what is density. So what is density? Well, density is kind of a way of figuring out about objects, about particles, about solids, liquids, gases. We can talk about density with any state of matter. So with liquids, what we're looking at with liquids is how much matter you can pack into a certain volume, and that would be the liquid's density. So, for example, we could say grams per milliliters is the measurement for density, and that is how much mass is in a given amount of volume. Okay, so today we're going to build a density tower using some different liquids. So there's lots of wonderful activities online and in books about density towers. They're all wonderful. I encourage you to try them all. The one we're going to do today is just with liquids. So we'll give it a try and see how it goes. And we'll learn about density along the way. So first of all, I'm going to put some water about halfway into my test tube here. And water is a very special liquid for many reasons. But water has a density of 1 gram per milliliter. That means for every 1 milliliter of water, there's a gram of its mass. So it makes it a nice standard to compare other liquids to, for sure. So let's take our second liquid, which is oil. So oil and water, which do you think would be more dense? So to answer that question, we can think about floating and sinking. So if oil is less dense than water, it's going to float on top of water. If it is more dense than water, it's going to sink to the bottom, okay, in our experiment here. So take a moment and predict where the oil is going to go. Is it going to go on top of the water? Is it going to mix with the water because it's the same density, maybe? Or is it going to sink to the bottom? All right, let's give it a try. Oil, water, pouring it in. And as you can see, the oil sits on top. Now, a lot of my skeptical students will say, but maybe it just hasn't mixed yet. Maybe it hasn't had time. So the only thing with oil is it does stay in clothing. So make sure you very carefully cover that hole up well and don't get it on your clothes for students and teachers. Parents, beware of that. Okay, so I did shake it. And as you can see, it did mix together for a few moments, and now the oil is just making its way back up to the top again. Okay, so that would tell us then that oil is less dense than water. So then it would have to have a density less than 1 gram per milliliter. Okay, so let's try another liquid. Let's try some corn syrup. So corn syrup is a rather thick liquid. Now we're going to get into viscosity in future videos, but it's a thick liquid. It moves pretty slowly. Now take a prediction. Where do you think corn syrup would go? Do you think corn syrup would go on, it's like a lot like maple syrup if you're not sure what corn syrup actually is. It's very similar. Do you think it would float on top of the oil? Do you think it would mix with the oil? Do you think it would float, mix in with the water, or do you think it would sink to the bottom? Make your prediction. Okay, let's try it. So we're going to pour some corn syrup in there. It's rather satisfying to watch, so take a look at it. Ooh, I think you probably saw it. Oh, and then it bubbled up. It sunk right to the bottom. So that tells us that corn syrup is more dense than water, and because it sank. So it would have to have a density more than 1 gram per milliliter. Now, the next one my students always like the best because they love food coloring. Usually, again, food coloring will stain clothing though, so it's something to be careful around. So I'm going to put a drop of food coloring in. And before we do though, let's predict. Will the food coloring sit on top of the oil, mix with the oil, mix with the water, drop to the bottom? Okay, let's give it a try and see. Ooh, just sitting there. It's cool looking. So in my class, I'd make students kind of wait this out. Oh, you just saw it move through the oil. That's fun. Okay, now it's sitting at the bottom of the oil. So again, with my students, I'd make them kind of wait because it's very satisfying to watch it finally hit the water. But I'm going to kind of help it a little bit by shaking it because this is a video and we don't want to wait too long for this miracle of science to happen. So, oh, it's being made in smaller pieces. Oh, there we go. So you can see it is sinking rather slowly, but it's also mixing with the water. So they call water the universal solvent because a lot of liquids like to mix with water. Oil is not one of those though. Oil and water, you've probably heard the saying, oil and water don't mix. Well, it's because they're very different particles. We'll just put it that way for now. But the food coloring and the water seem to blend well together and they're mixing together. So they probably have a similar density. Okay. Now the last liquid is my final step. I always like to use this step, is to put in some dish soap. So I'm going to use some dish soap here. So before I pour in dish soap, and you know, dish soap is rather important when you're washing dishes because what it does is it allows you to clean things that possibly are oily. So how does it do that, I wonder? Something to think about. But it is fairly thick, I would say, when you're trying to pour it out, you know. Who thinks it's going to float on the oil? Is it going to mix with the oil? Is it going to mix with the water? Is it going to float? Is it going to sink to the bottom? Okay, well, I hope you made your prediction. I hope you predicted well. And if you didn't, you will definitely learn something. So there it goes in. It's making its way through the oil there now and heading down. It's very fun to watch. Heading now down, down, down into the, oh, it got stuck. It got stuck in the oil. Oh, there it goes now. Ooh, that's fun to watch. Big glob of it just dropped. So the oil slowed it down, but it really didn't stop it. So we can safely say that the dish soap is more dense than water and sunk to the bottom. Now, if dish soap is supposed to help us clean and doesn't mix with water, what's going on? Well, there's something we're missing here, and that's called bubbles, right? So usually when you put dish soap in, it bubbles up and it helps to make it mix in with the water and the oil and keep the oil separated from the water for a bit. So we're going to shake this up and let the soap do what it does best. So if you take a look at it now, it has mixed together the oil and water. They have had a momentary truce and they're actually mixed together. And why that is the soap actually breaks apart those big blobs of oil and allows the water to mix in and do its thing. So there you have it. Now what's cool is to let that sit overnight, and then you'll see that actually the oil will separate itself later again, and the soap kind of stays mixed with the oil and the water, maybe a little bit in each. I'm not really sure where the soap goes afterwards, but it certainly isn't at the bottom anymore. So cool science. Hope you enjoyed it, and I hope you have a great rest of your day. Join us again for another episode very soon.